Today I will review and explain the physics and electron engineering. First, you have to know the Ohm's law here. The Ohm's law, we normally know that Ohm's law is V equal IR, but when on the semiconductor field, you can use the Ohm's law like this: J equal QNUE. When you see the carrier in the space, that and then when you when you give the electric field to the carrier, then the carrier has the force and move to forward, but there are many atom or other forces, so the carrier will scattering, so the carrier has low mobility. The mean free path means that the how long the carrier is going without other stress. So when the mean free path is high, that means the mobility is also high. In the same way, if the mean free time is high, that means also the mobility is high because the carrier go straight without any other stress. The Ohm's law, J equal Q and U is the very useful equation. If you want to make a high-speed device, then you should increase the number of carrier or mobility or electric field. The high-speed device means that the carrier has high drift velocity. The drift velocity Vd equal mobility and electric field. If the mobility is high, that means the electron can move fast, so drift velocity is also high. Next, you can see a PN diode here. A PN diode means when the N-type semiconductor and P-type semiconductor is connected each other, and then we can draw an energy band diagram like this. Now let me tell you how to draw the energy band diagram. First, you should consider the thermal equilibrium state. You should draw one long line, the Fermi level energy of the N-type semiconductor and P-type semiconductor, and then you should draw the conduction band and valence band each other. If the carrier has its distance is depend on how much the carrier is on the semiconductor. So if the semiconductor is highly doped, then you should draw a Fermi level and conduction band very closely. So we know the this distance to how much the carrier is doping. This is the depletion region because two different type of semiconductor is connected, so it makes depletion region. So this region we can see the electric field is left to right. Also we can see the charge on the depletion region. Because this is the n-type semiconductor, we can draw a charge like this, and then here is the p-type semiconductor, so we can draw negative charge on here. If we know the charge of the depletion region, then we can also know electric field here, like this. This picture means that the electric field is high or max at the connection surface. Next, next is the MOSFET. MOSFET structure has gate and gate insulator and piece of substrate like this. There are three modes of the MOSFET. The first one is accumulation, and then second one is depletion, and last is weak or strong inversion. When we give the minus bias on the gate, then insulator makes the capacitor, and then we can accumulate the hole in the insulator surface. The P substrate has lots of hole, but we can accumulate here more hole, so this means accumulation mode. Next, when we give the 0 or some a little bias to gate, then it makes the depletion region here under the insulator. Because of the repulsive force, it makes the depletion region. When we increase the gate bias, then the more we give plus bias to the gate, then the more depletion region is increasing. However, when the gate bias is excess to threshold voltage, then it turns the strong inversion region. When we give the high plus bias to the gate, then we can see a negative charge under the insulator surface, but this is the P substrate So we can we say that a strong inversion region is here. So we can use the MOSFET tunnel in in this inversion layer. So let's see the capacitor of the oxide graph here. When we in the accumulation region, there is no change of the oxide capacitor. But when we give the some plus bias, the depletion region is increasing, so the capacitor and a depletion capacitor and insulator capacitor is getting harmonic averages, so the total capacitor is becomes lower. Then if we access the threshold voltage, then MOSFET will turn to weak inversion or strong inversion. There is no change in the MOSFET. Thank you for watching my video.